Good day, grade 11 chemistry students. Today what we're learning about is concentration again, but we're focusing on something called the dilution equation, which is right here. Now, the dilution equation deals with concentration in molarity, which means moles per liter, per 1 liter, okay? What it says is if we have our initial concentration, that's what that I stands for, times the final volume, times the initial volume. So initial concentration times the initial volume is equal to the final concentration times the final volume. We're going to start with a couple of questions which will help illustrate why this equation works better than our old equation, which is, I'm going to say C equals N over V, which deals with molarity. And we use this equation for specifically for dilution or concentrating type questions. So here's a problem that will help us understand why the dilution equation works best. It says if you take 15 milliliters of a solution of a 2 mole per liter AgL solution and transfer it into an empty 500 milliliter flask, how many moles were transferred? So here's our volumetric flask, and what we said is we're going to transfer 15 milliliters of our solution into it. So we fill up to about this mark here, way down, we fill it up, and it looks like a clear solution. It looks like just pure water. But we know that it has a concentration of 2 moles per liter of AgCl. We also know we transferred 15 milliliters. Now what is that? Well, that actually is my volume, and moles per liter is my concentration, okay? The second part of the question says, if we take a look at it again, we're going to fill it up to 500 milliliters. But to finish off the first part of the question, it says how many moles were transferred. Well, how many moles are in this solution that we have at the bottom of this flask here right now? We've got 15 milliliters, 2 moles per liter. Well, if you think about it correctly, hopefully you figure this out. We know C equals N over V. So therefore, N equals C times V. My concentration is 2 moles per liter. My volume is 15 milliliters. But I'm going to convert this to liters, and the reason is, I'll show you in a second, we divide this by 1,000, and we end up getting 0.015 liters. The reason why we do this is so that our liter units cancels out, and we get an answer. And our answer will be 0.03 moles. So when we added our 2 mole per liter solution, we only added 15 milliliters of it. Because if we added a whole liter of this 2 mole per liters, we would have added 2 moles. But we didn't add a liter, we added 15 milliliters. So that means we're going to add less than 2 moles. In this case, we calculated we added 0.03 moles. Now, let's look at our second question. The second part of the question says, okay, we are now going to fill it up to the 500 milliliter mark. So we're going to add water now. Now we add distilled water into our flask, and we fill it entirely up with just pure water. We're not adding any AgCl, no other chemicals are being added, and we fill up the entire thing. Now, what's my new volume? Well, my new volume is clearly going to be 500 milliliters. And the question asks, if we recall, what is the new concentration after we fill it up with 500 milliliters of distilled water? Now, what are we doing to this solution? Are we concentrating it or we're diluting it? You should realize immediately that we're diluting it. We're adding water, so therefore the concentration is going to go down. The amount of moles stays constant. So we say, again, to find the concentration, our new concentration, we go C equals N divided by V. Now this is a new volume that we have here. The volume is 500 milliliters. So I put my concentration, 0.03 moles, and we divide it by my volume, but I'm going to convert this to liters, so it's 1 liter for 1,000 milliliters, and that will be divided by 0.5 liters. So my concentration, my new concentration, is going to be 0.06 moles per liter. Sorry guys, actually I did that wrong. No, I did that correct. Sorry about that. It is 0.06 moles per liter, and this is our answer. Remember, we started with 2 moles per liter. We put 15 milliliters in. We filled it up to 500 milliliters, and my new concentration is 0.06 moles per liter. Okay, let's look at the alternative way to solve this problem. And we're going to use the dilution equation. And I want you to use this way from now on. Now we realize this is a dilution equation because we're adding water, which is causing it to dilute. Now C is obviously going to be concentration. And it says I is going to be initial, and F is final. So again, if we look at our solution, we know that initially we had a concentration of 2 moles per liter. Now I'm going to say I because that's what I started with. My initial volume that I have, that I added or transferred, is 15 milliliters. The final concentration after we dilute it is what I want to find. So the F means final, C means concentration, and the final volume is what we diluted it to, which is 500 milliliters. Now all I'm going to do is just fill in my numbers here. So my CI is 2 moles per liter. My VI is 15 milliliters. My CF is, well, I don't know what my CF is. That's what I'm trying to find. And my VS is 500 milliliters. Now look at my units. This is why it's so important for you guys to really use your write down your units. So we have 2 moles per liter times 15. And since 500 is being multiplied on this side, it's going to be divided on the other. And this is what we get. Milliliters will cancel out, and CF is going to be equal to 0.06 moles per liter. And that's pretty much how we use the dilution equation. We write down what we know, use I's, V's, and F's, and it actually saves us time when we do our calculations. Specifically, we're looking for dilution equations where the amount of solvent is changed. Or concentration type questions. Concentration where you're concentrating a solution, and you really have 3 values. Okay, so for tomorrow, I'd like you to try this question. What is the concentration of a solution if a 10 liter of 2 mole per liter solution of Na2SO4 is boiled down to 1.7 liters? Immediately realize that you're going to use CI/VI equals CF/VF because you have 3 values in the question. You have to take a look at it, decide what is the initial situation, what is the final situation, and then solve for the unknown. Go ahead and do that and show it to me in class tomorrow. Enjoy your evening. When things are big that should be small, who can tell what magic spells we'll be doing for